Hey everybody, welcome back.
Hello.
We are on Module 4 of this session on developing Windows 8 apps using the web platform. And Module 4 is all about JavaScript. So we're going to jump into, right now, the JavaScript core capabilities. Obviously, we're going to leave some things out, but we're going to get to those in a subsequent module. So stay tuned for sure. JavaScript is an interesting beast. I like to say that it's the weirdest language I've ever loved. There's just some oddities with the language that are peculiar. But it's great. It's actually a wonderful language, and it's really awesome that that we're built on this stack now. We've got all the benefits of JavaScript brought into the client world, so it's pretty exciting. Let me introduce you to the content that we're going to cover here. We're going to be looking at an overview of JavaScript itself, the language, and then we're going to look at a few of the core tenets, the basic principles of JavaScript development. It might be a review for some of you, which is completely fine. But we're going to look at the variables, the nature of functions in the JavaScript language, and what the implications on the function scope is for us. And then we're going to look at arrays, and we're going to look at objects. And that covers a lot of the basics. You don't necessarily get into the control structures and the prototyping and a lot of the more advanced things, but we can definitely pick those up at another time. So let's first climb right into the history of JavaScript. Again, might be review, but JavaScript's been around for a little while. 1995, Brendan Eich was an employee at Netscape and started working on JavaScript as a way to give a little bit more control over what was happening on the client side after they downloaded their web page from your web server. We wanted to add a little bit of functionality to that client side, take a little bit of the work off the server, not just deliver content and be done, but be able to traverse the content and say maybe move things around or conditionally show things or hide things. So that was the effort. In '97, it got formalized by ECMAScript, so it's now a formal standard. And a little bit of trivia here. Any idea what ECMAScript stands for? What is the ECMA?
It sounds like that thing on Roadrunner and Coyote. You know?
No, that's Acme.
Oh, well, that's Acme.
Yeah, the bomb brand.
Yeah,
right. No.
Yeah, ECMA is, I don't know.
Yeah, ECMA's different. ECMA technically doesn't stand for anything.
What?
It used to. It's an old standard from like the 60s, and it was the European Computer Manufacturers Association. But now it is officially just ECMA. So I think it's kind of like KFC. Used to be Kentucky Fried Chicken, no longer. It's just KFC.
Oh, that's a good analogy.
Yeah. Anyway, there have been a lot of advances in the JavaScript. It's been evolving over the last couple of decades, and with a really interesting evolution, and lately has just gained a lot of momentum. In 2009, it moved to the back end with Node.js. A lot of excitement about Node.js and actually writing JavaScript on the server with Node.js. So that's exciting. And then in 2012, in just a few days actually, it's moving to the client with Windows 8.
And I think what I really like about how you showcase that, when most web developers think about JavaScript, they're always thinking about JavaScript running in the context of a browser, which is normal for everyone to think, right? That Node.js comment was really good because it is on the server. It's something operating on the server that can dish stuff down to the client. So we started getting everyone familiar with the idea, or people started getting familiar with the idea that JavaScript doesn't have to be just a browser language. So I love that you brought that out so that it can transition easier to how it can be an application language as well.
Yeah, and you can see that some of the provisions that it gives for us are really interesting because we're on a client, we're in what's normally considered a more controlled environment, and yet the dynamic nature of JavaScript just kind of opens that wide up. So you'll see what I mean. You'll understand here soon. JavaScript is not officially an object-oriented programming language. It's prototype-based. And that works completely differently. You can emulate objects, but you don't have classic objects, classic inheritance, or anything like that. It's also dynamic and weakly typed. So dynamic means you can just drop properties onto objects or whatever anytime you want, anytime in the cycle. And if you get yourself in trouble, that's your job as the developer to make sure that those are checked, those are resolved, and you're not letting the user know that you're in trouble.
Yeah.
Weakly typed meaning that you don't have a strict rule that says that if you call this a string from the get-go, it's going to have to act like a string. Everything's declared with a var. And so that's the weak type nature. Variables, a function can receive a variable of whatever type. It doesn't have to be decided what type that is. And you can even make decisions then based on the types that are passed into your variables.
Yeah.
It does consider functions to be first class. So functions are objects, and they can be thrown around, moved around, manipulated. Properties can be added to them, just like any other object in JavaScript. So the way that JavaScript treats functions is a bit different, and Michael's going to talk about that a lot more coming up soon. But thank goodness, JavaScript is C-like syntax, so it's got the same angle braces and semicolons that we're used to, pretty much the same structure that we're used to. So it's going to look really familiar, even if you haven't worked with JavaScript much before. It's going to look really familiar. Now, the first thing that we're going to start with is variables. We're going to declare variables so that we have a place to store things. And the things that we're storing, it could be almost anything. It could be a string, a number, Boolean, array, this catch-all object, which could be, absolutely anything that you want. And then a variable can also be at any point holding the value of null or the value of undefined. So if you ask about a variable and it doesn't exist yet, then it's going to say that that is undefined. If you ask for a variable and it hasn't been initialized yet, hasn't been instantiated, then it's going to declare that that is null. That's what it's going to report. So let's look at some of the variable definitions. Now to do this, you won't be able to go into the Code Show project because some of these demos are just going to be quick little changes that I'm going to make for you kind of on the fly. And so there's not a Code Show demo for it. I'm just going to jump into what I call my sandbox, type some code, and then we'll run the app and see that code happen. Now I did, in my log function here, I am outputting the function that I wrote. So when we get to the app screen, you're still going to be able to see the code. So hopefully that's a little bit handy. Let's go ahead and write some code. Let's go to this onReady function, and let's write var myString equals hello world. There we go. That's how we declare a string variable with the var keyword. And if we were doing a Boolean, we would do it the exact same way. Okay? So we're using that var keyword, whatever type we happen to be using. And then in my little sandbox app here, I can log my string. And we can run this. And as I mentioned, you can still see that code there, but you can see that it's logged out this string hello world. So that's how we store things. That's how we receive things from functions as these variables. And that's really all there is to say about variables. Now, beyond variables, we're going to get into functions, which of course are objects, and so they can be stored in variables. But functions have really interesting behavior in JavaScript. And so I'm going to go ahead and turn the floor over to Michael, and he's going to tell you about functions and function scope.
Yeah, as was mentioned by Mr. Jeremy, functions are a first-class citizen. They can be used so many different ways, and we feel, and in fact, I feel like there's almost this discovery if you're coming, especially from a strongly typed language. I was very passionate about C#, and I wasn't necessarily just all in with JavaScript. So coming into the JavaScript world, I really got to see, wow, there's a lot of power with functions. So what I want to do is just take a tour of how to get started with them, and then we're going to progressively see how advanced and how powerful they can really be. So let's go ahead and take a look now at our agenda. Up to this point, of course, we've had our overview. We've discussed what variables are, how to do some basic assignments, and now I want to get into some of the simple functional aspects of functions. No pun intended. So, how could you describe what a function is within JavaScript? I think I like the first line there. It's a callable behavior. That's one way to look at it. It's something that you're going to execute. But it is implemented as an object, which means it has other features, like being able to play around, pass them around, take them in as arguments to other functions, so they can get really interesting there. And then there's this concept of even hoisting. Now, what do you think that means, Jeremy? Hoisting.
Hoisting is something that in other languages you may kind of take for granted, but when a function is hoisted automatically, that just means that if the function is defined below the code where it's actually called, that's completely acceptable. The compiler has looked ahead and seen that there are functions defined later in the code, and those are acceptable. But when you define your code in that way, it's okay. So let's go ahead and look at my screen here real quick. I'm going to I'm going to declare a function like this. Function, I don't need to receive anything. Actually, I'm going to give it a name, my function. And here's the body of my function. So that's a perfectly valid operation there. But there's another way to define a function, and that would be like this. We'll call this first one, actually let's call it f1, and we'll call our second one f2, and we're going to show it like this. Okay, so those are both valid functions. This one is called f2, and its value is a function. And this one is called f1, and it is a function. But because this one is using the classic syntax for defining a function, first of all, it doesn't need a semicolon at the end. But this one technically does. It'll work without it, but technically that one needs a semicolon. Now let me go ahead and above both of these functions, I'm going to try to call log, and I'm going to log the results of f1. So I'm going to call f1, and then I'm going to say log, and I'm going to call f2. So before these have been defined, I'm going to try to call them, and we'll see if that's successful. Go. Bam. I dropped right out because I used Control F5. Now if I hit F5, I'll actually go into debug mode in Visual Studio, and now it'll stop at that breakpoint and let me know what's going wrong. And it's saying, hey, I expected an object right here. You told me f2 was a function, and I haven't seen that as a function before. So let's go look at this. In fact, f2 has not been declared as a function yet. But it had no problem at all with f1 because it was defined in classic function syntax, and so it's been hoisted. Now, one more thing I want to show you about the behavior of functions is the behavior of arguments in them. So, first of all, let me go ahead and modify this a little bit. I'll get rid of f2 altogether, and for f1, you can see that I'm calling f1 and I'm not defining any arguments in here. This would be an argument definition, A, B, and C. But I'm not going to define any arguments there. But when I call it, I'm actually going to send some arguments. So we'll call this 1, and we'll call this 2, and we'll do 0.78, and we'll do a dynamic object, and we'll do a dynamic array. We're passing all kinds of stuff into this function.
So let me get this straight. You've defined this function to take no arguments, and you're breaking the rules, so to speak, and you're saying, I don't care. I'm going to pass these in anyway.
Absolutely.
Interesting.
Absolutely. So now let's go drop down here into our function, and I'm going to use a magic keyword here that some people haven't seen before. Debugger. If you just put the word debugger there, it's like making a breakpoint without having to type a statement and put a breakpoint on that statement. So if you just type debugger and hit F5, bam, you land at the debugger because we called this function here, and so here we are. And here we can open the JavaScript console, and we can look at what's been given to us. It looks like nothing's been given to us. At least we haven't called them by name, but we can look at this arguments variable and see that it actually is an object, and it has 5 things in it. So look at that, 5 things that were passed in.
You got me confused here. You went into this Java console, you typed the word arguments. Where was that declared?
Arguments was never declared. It's an inherent part of every function, and I'm in the context of this function right now. And so right here, arguments is perfectly valid syntax.
Wow.
Yeah, and so I could, for instance, I could refer to the 4th thing that was passed in. That should be this dynamic object, and I could refer to that 4th thing with a 3, and that would be an object. I could refer to the first thing that was passed in. That would be argument 0, and that would be the word 1.
Wow.
Yeah. So those are just a couple of characteristics of functions that make it interesting developing in this world.
That's cool. Thank you.
Yeah.
Well, so I appreciate the thought there on the hoisting and the arguments. I want to go back and talk about something that was actually done in Jeremy's code sample, but we didn't really formally talk about it yet. So I'm going to just talk about some of the basics. In fact, there's different kinds of functions. There's functions that just do something. So think of that as I execute, I do, I don't return anything, I don't take anything, I just do, right? And then there's I get something types of functions. So in the second example, it's just saying, hey, you got something to return, then you're probably going to use the return keyword and you're going to return something out of there. That seems reasonable. You already talked about arguments. whether there's 1, 2, or I guess in your case, none. If you're using the arguments keyword, that would work as well. But now I want to show a different side of this by talking about this term method. And so what we're doing here is we're declaring a variable, as we learned when you chatted about variables. It's called ops. And ops is equal to, it has that open curly brace, and then you'll notice down below it has that closing curly brace. In fact, if I just zoom in right into that, you'll see this is basically where ops ends, right there. And what we've defined in between this curly brace and the other one is the ability to have a function named add, and it's a member of ops. Once that function becomes a member of this curly brace thingy, which we'll just call an object for now, we'll say that object happens to have an add method in it, and that add method is a function that takes 2 numbers in and returns the result of that. So down below, if I say var x equals ops.add 3, 5, well, 3 and 5 get passed into here, and then they're added together. That's why we get that x equals 8. But I can't call ops.add numbers, even though that's the name of the function, which is kind of interesting. But before I explain why it's not valid, I do want to say that the magic here is just kind of saying if you're going to hear the terms methods or functions, the primary difference between the two, well, look at it this way. A method is a function. So, I mean, we're not trying to say that there's something different other than the fact that it's the context of where the function's being called. If it's a named property, like in the example of ops, where it has an add function off of the object itself, we could say it's a method, which is really a function. So just getting a little nomenclature out of the way. But going back over into our example, why is it not valid to say add numbers? So you have any guesses on it?
It looks like it's hidden to me.
You are correct. And in fact, that is what I'd like to get into right now, and that is scoping, which is it's a pretty big deal, especially when we're dealing with our Windows 8 applications and we're trying to figure out how we're going to do proper structuring of our code. A lot of it has to deal with this topic, and that is function scope. So everything we've talked about so far kind of leads to some functionality, and now we're going to go a little bit deeper into some of the advanced features of functions with regard to scope. So when we say function scope, and when Jeremy said looks like it's hidden, that's because it was. Now, if we intentionally know that, that may be exactly what we're intending to do. And the reason, why would you ever want to reduce anything explicitly in code? I mean, or minimize it or hide it. Do you have any thoughts on that?
Yeah.
Why would you want to hide anything?
Yeah, I think that I don't want to have access to things that I shouldn't have access to. So I want to hide them.
Sure. And the other thing, too, is if you have a whole bunch of functions, let's say you have hundreds of functions, but in reality, at the application level, you really only need to call a few of them in order to do what you need to do, and a lot of them are just helper functions. Well, you could reduce the complexity of your own little APIs, if you will, by not revealing all the unnecessary helper functions that might be doing it's kind of like literally a car. You look under the hood, you're glad it has an engine, but the behavior that you care about is turning the key, and which makes the car start, right? That's the most important function of all to you. You don't care what's happening under the hood. What if you had to do all the stuff under the hood? You had to manually tweak the spark plugs in order to, it's getting complicated now to start to drive. So it's kind of the same thing with your code. If you could just make available what you need to do in your code, you can hide certain functionality, mask certain things, and it makes it a lot easier for you to call. So whether it's you shouldn't have access to it or you don't want to have all sorts of unnecessary choices to make, then you should consider doing data hiding, which can be done with our discussion here on function scope. And that's really what encapsulation is. Encapsulation is an object-oriented terminology. It's one of the facets of an object-oriented language, and that's the ability to do some data hiding or encapsulating behaviors and having indirect means by which you can call them or retrieve data. So let's look at this example of scope. We have a variable called x that's equal to 2000. Then we have a function called sumFunc, and we have a variable inside of that function that's equal to 12. And then we also immediately return that variable value from the function. So down below, if I try to say variable z equals x plus y, it's an invalid use of y. And so what would be the reason for that?
It's hidden.
It's hidden. We declared the variable in a function. That means it's not accessible outside of the function in terms of accessing that actual variable directly. However, because we returned y in the function, that's why the next line of code is valid. X plus sumFunc, executing it, which returns the value of y. That's the example there of retrieving that hidden value without actually getting to the specific variable name. So very simple discussion there on one level of scope. Now, this is the thing that was being done. If you didn't notice it, we've been declaring functions in some of our samples, but if you were looking at the outer context, we were declaring functions inside of functions. So this is just another example of what that would mean, and we're especially going to look at the scoping aspect of it. The first function there is called outer function. Notice it takes in an argument of n. Now, once we have that value of n, notice that the inner function, which takes no arguments, can return n times n, and that would seem to make sense because n's being passed into the outer function. That means it's scoped to everything within that function, even functions defined within that function. Sounds complicated, but it will actually work. It'll return the time, the value of itself times. So we return the inner function as the return value of that outer function. So if you say variable x equals outer function 4, then ultimately the returned value is going to be 16 because 4 times 4 will equal that. But I can't access that inner function directly. So again, think of that inner function going back to the analogy with the car. That's your engine. That's an engine component inside of this other object, this other function. That's saying, well, you don't need to tweak the certain things directly. You could just call this bigger outer function, and if it happens to have helper or supporting functions inside that are doing some specific algorithms or specific work processes, you don't even need to be aware of that. You just care about, hey, I'm calling you, I want to get a result back, and as long as it's doing its job, regardless of the complexity inside, it's okay. So, but that's important to understand because if you're declaring inner functions and outer functions, at this point, they are completely hidden. So you've also eliminated the possibility for yourself to call it if you wanted to call it independently. So let's go ahead and return back now and talk about immediate functions. And there's a couple ways that these have been referred to. Sometimes you'll hear them called self-executing functions. And I'm giving you two flavors on the screen right now, how they can be declared. And this is what I mean. These red braces over here are indicating the outer braces of the first one. Whereas over on this side, you'll notice that these square or these braces or parentheses are on the outside. Both styles work. The main reason why you would do this is because you want to have the code, which is really represented by the ellipsis in both of these examples, to execute as this is being processed. That's a very interesting thought, because when we typically think of functions, if I go back one level, back to functions and functions, when we declare functions and they look like this, well, nothing really happens by declaring the function. It's when we do that last line where we say var x equals, by calling that function, that's when it actually executes. What we're saying with immediate functions is that they're going to execute immediately, as the name implies. So you need to be careful here with the use of immediate functions. because they are going to execute right away. And if you put them in the wrong place or use them unwisely, there might not be resources available to you yet as you're actually executing them. So use them carefully. But the advantage that they bring is that you can create a whole bunch of content in them that will be hidden from view. So they're not going to be shown anywhere. One example that's very popular on the web right now is something called the module pattern, which makes use of these immediate functions. So to put it into perspective, var mod, which is the name of mod is the name of our variable, is equal to the result of calling an immediate function. That means that the variables that were declared in there, such as m, c, d, and y, they are not in the outer or global scope of the JavaScript working space whatsoever. Because this function is returning a value, it returns an object, and inside that object it has a method in it called getHiddenNear. So down below, when I look at var x equals, mod getHiddenNear, this whole line here, which is really cool to talk about, this whole thing is possible to call that getHiddenNear, even though it was inside of that function, because it's being returned as a method of an object coming out. I can't say mod.m, mod.c. That's not going to work because those were declared inside. But I do have that ability to go in there and call that method, which will return the correct result. So this is an opportunity for developers to explicitly create what they want exposed outside of that immediate function, and yet keeping everything else hidden away. And you'll notice that we're also making use of, and I don't know if we've explicitly mentioned them yet, but I'll just show it right here, that this would be known as an anonymous function because we didn't provide it a name. So, but it does have a name as a method, getHiddenNear, which gets exposed to the outside. So pretty simple in terms of implementation, but be careful with the conceptual use or the architectural use of these, and make sure it aligns well with whatever it is your architectural strategy is for your code.